forget to record for these absent children. Okay, let's just start running. No printed notes. I wanted you to get used to writing again. I knew you would need some.
No, I'm not gonna lie. It felt really weird writing it first time. I was like, what is happening with my handwriting?
AP Calculus has a test tomorrow. How about that for a good writing?
That's not very nice at all.
But I did give them a take-home AP test over break, so they never really got stuff. So.
Did they all get okay by then?
So I'm pretty depressed right now.
Mason wasn't here today, and Jessica Jones wasn't here today, so they must be at home working on their homework. So.
Need some therapy or something?
I could give you the energy with that. You could go read it with multiple stories.
No.
That would be depressing.
I don't want to come.
Long.
It's alright.
Feel a lot already.
It's alright. It's the first one. We got 25 days.
For a grade.
25 days to figure out. Okay?
And it's for a grade.
A curved grade.
Whoa.
Yes, it's for a grade.
What is for grades?
That AP test.
The AP test they took over spring break.
Oh.
I'm so sorry for you. Did people not do it?
No, everyone's. I mean, Mason wasn't here today, and Jessica Jones. So we'll see. Not sure. Yeah. She's doing it right now. Probably.
I think Mason thinks so.
Mason.
That's just too hard.
That's why I don't make you memorize them. But these are called double angle formulas. Why? Because there's a 2 up here, right? We haven't ever seen that before. Sine of 2u. We don't know what to do with that, but now we do. We can sine of 2u is the same as saying 2 sine of u cosine of u. Tangent's always the division. Tangent of 2u is 2 tangent of u over 1 minus tangent squared of u. And then cosine of 2u is written 3 different ways, and it's just because you could make all these ways, but sometimes one is easier than the other, so I just gave you all 3. I should have bought a new microphone over break. I keep forgetting that's broken. So we could prove where these other 2 come from here, because if you just replace cosine squared with 1 minus sine squared, that's where you get this. You get 1 minus 2 sine squared. And if you replace sine squared with 1 minus cosine squared, that's where that one comes from. Again, you don't have to memorize any of these, so I don't stress too much. I'll give you this exact formula sheet on the test, so you just have to know how to use them. So we're going to do some things where we're solving equations. We're going to do some things where we're proving things with these, and just get used to working with them. Okay? We're done running those. Just take nap time today.
Yes.
I have a test in my class that I'm taking at ISU on Wednesday. April Fool's Day, I have to take a test there. So I'm really okay. I could just study and you guys could just sit quietly. Everybody done writing this? No? I'll wait for it. Colin, there's homework on there.
I know, I saw it. I thought you were just giving us like one to study.
Okay, I'm going.
Yeah, that's started. Gotta start off there.
We haven't solved trig equations in a while, but remember we can solve from either 0 to 2 pi, or we can find all solutions. But the idea is you want to get to a point that you can set a trig function equal to something and you can solve it probably without a calculator. Great, write this down. Don't fly, I just can't fly. You can't just move the 2, but I just gave you a formula for what sine of 2x equals,
Yeah,
right?
I know, but that's just. Give a sign of 2.
U is just u, right? So we're not proving anything. It says solve.
I am you. You are you.
You are wrong.
We are all.
So we did this back in 5.1, 5.2, I think it was 5.1, which is a while ago. But the idea is we want to get to a point that we can do this using our unit circle, using our special triangles. So the idea is, hey, I have a formula that I just learned that sine of 2x is the same as saying 2 sine of x cosine of x. So like I said, you don't have to memorize that, but you have to know when to use it, and this would be the time that you'd want to use it. And remember that it's not a good idea to divide by a trig function. It'd be really great. You could say, let's divide by sine here, because then those signs will just go away and life will be easier. But if you divide by a trig function, you're missing out on some answers. So a good strategy, if you go back and look at your 5-1 notes, we said get it equal to 0. That's a good strategy when you're solving an equation. So what if I subtracted the 2 sine x over? Is that okay? I know, it's Monday after break. I'm just expecting I'm just going to pull you through today. And then you want to look for some algebra things like factoring or, I don't know, factoring probably. Can I factor here? I think I can pull a 2 sine x out of that. Can I do that? 2 sine x, and what would I be left with? Why do we like to factor? Because we're allowed to break up multiplication. The zero product property says if 2 things multiply to give me 0, I can set each one equal to 0 and solve it. So if we can separate those trig functions, can I now say 2 sine of x equals 0 or cosine of x minus 1 equals 0? Remember doing this? This is where then you have to go back and remember your favorite unit circle special triangles, and you have to tell me what values make this true. I could divide the 2 over, and that would just be the same as saying sine of x equals 0. So from 0 to 2 pi, notice 0 is included, 2 pi isn't. On some worksheets and homework quizzes that we've taken, some people give me 0 and 2 pi as an answer, and I don't really mark it wrong, I just mark it out. But I want you to be aware that 2 pi is not an answer that you can give because it's not included, right, as parentheses next to it. Maybe a hint there that that's the answer here, right? Where does sine equal 0? Sine is y, right? So at 0, at pi, not at 2 pi, because 2 pi is not included, right? It's true, sine of 2 pi is 0, but it's not included in that interval, so we would just say 0 to pi, or 0 and pi, sorry. And what about this one? If I added the 1 over, I would say cosine x equals 1. Where does cosine x equal 1? Not 2 pi. But 0, we already said 0, so do I need to say 0 again? It's not wrong if you do, right? It's a little redundant, but 0 pi. Or 0 pi and 0 again. This is a nice refresher. Look how much math we just did in one problem. Let's do another one. It was okay. He's all better. And the flu's all gone, then we're good.
Yeah, you didn't get any of us sick. Well, I mean, this girl's got sick, so it's maybe you got sick.
I never got sick, so I know that.
You just take care.
My kids didn't lose their voice. They just had flu.
Hey, sometimes it doesn't for everybody.
So when I see cosine of 2x, I think we should use one of those identities, right? And this is the one where people struggle because they're like, well, which one should I use? You have 3 choices, right? What were your 3 choices?
There's
Cosine of 2x, 2u, I'm going to change the x's.
minus sine squared.
Cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. It's pretty squished, but that's what you should have on your paper. We want to replace this with one of those, and it really doesn't matter. One just might be less work than the other. How do I decide? I look what's over here. What's over here is a sine. So which one do you think would make the most sense to replace? One that has cosine and sine in it? One that only has cosine? Or one that only has sine?
Bottom one.
Yeah, why not pick the one that just has sine in it so that they're already all in the same trig function? If you pick one of the other ones, you're just going to have to do some more substituting later using your identities. So that's why they give you 3 versions of the same formula, so then you can decide which one's better. So I'm going to do 1 minus 2 sine squared x equals sine of x. And look what we have here. It's not really in order, but we have a squared sine. We have sine that's not squared, and we have a constant. What does that look like? Like a quadratic. So it looks to me like we're going to factor this by like undoing FOIL. I'm going to put the sine squared first, and I'm going to actually move it to this side so that it becomes positive. You can just divide by negative if you want, but I'm going to move it over here. So I'm going to make that positive 2 sine squared. Keep the plus sine x, and then I'm going to subtract the 1 over and make it minus 1. Right? So I'm just taking these two and moving them over. Oh, and it's the favorite factoring because it has a 2 in front, right? Factor by grouping. If you guys don't like my other way of factoring, don't erase the 2. Right, we're going to multiply these together. 2 is a prime number, hopefully, but not that bad to do. Well, multiplies to give me negative 2. That subtracts to give me positive 1. Positive 2 sine of x minus 1 sine of x. That's a lot on a Monday after 10 days off. I feel bad for the people watching this video because I just keep hitting this microphone over and over again. It's 10. I always know. Parker likes to know how many days off he gets, so we always know how many. I know. Easter's this weekend.
Yeah, it is.
So I could factor out a 2 sine of x, and I'd be left with sine of x plus 1. I could factor out a negative 1 and have sine of x plus 1. Some people have told me that they don't remember how to factor by grouping. You got to know how to factor by grouping. What do I do from there? Set each one equal to 0. It's all in terms of sign, but we still have to set each one equal to 0 and find all the solutions over that interval. So if I set this equal to 0, I'm just going to say that gives me negative 1. And I'm just going to go ahead and solve that if you're okay with that. I'm going to add 1 and divide by 2 and get sine equals 1/2. Without a calculator, these should always be numbers from our unit circle. They could be terrible things, and I could let you use a calculator and you could give decimals. Like I could say, where does sine x equal, I don't even know, 0.2765, and you'd have to use the button on your calculator. But I like the ones that you get to use your unit circle. So sine is y, so where does sine equal negative 1?
Obviously, it might have sine. You might have big number.
Where does sine equal 1/2? Oh man, that's a harder one. Oh, it's a terrible one. Up here, right? Nope, down here. Right? Draw it out. Which means pi 6? Is that the only place that sine equals 1/2?
No.
Where else is sine positive?
Pi 4, pi 6.
Pi 6. It's nice that we keep reviewing this over and over again because it's going to be a lot of your final, right? Like we spent forever talking about the unit circles, so. Which means there are 3 angles that make that true. How do you feel about that? Let's try something different. Okay, I want to show you another way to do these problems if the trig function, like there's only one and it's a cosine 2x or a sine of 2x, and then we can talk about, we can use the formula probably as well. Could I get that cosine of 2x by itself?
Yeah, divide by 2.
I could just divide by 2, right? So I could get cosine of 2x equals 1/2. Yes? So we have these formulas, and we can go and look at them. Probably the one that just has sine squared or cosine squared in it would be the best choice here. But I want to show you how you could do this without using those formulas. If it's just this trig function and not another one with it. What if that just said cosine of u equals 1/2? Would you be able to tell me where cosine equals 1/2? Yeah, and normally we just say like x equals blah 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 blah. If you have another number up here, you can do the same thing, and you can say where does cosine equal 1/2? But that's not what x equals. It's going to be what 2x equals. So let's think for a minute. Forget about the 2x, and just tell me where does cosine equal 1/2? No, that was sine, right? Pi thirds. And cosine is positive in what other quadrant? 4. So if it's pi thirds, what else is it?
5 pi thirds.
That's where cosine equals 1/2. We want to know where cosine of 2x equals 1/2. So if I write it like this, what would make sense that we would do to get x by itself? We could just divide by 2 here. And if I divide it by 2, hey look, Grady, it turns out it's the answer from the last time, right? Pi 6. You agree with that? Dividing by 2 is the same as multiplying by 1/2, so that just becomes pi 6. And that becomes 5 pi 6. Hold on, there's a... But there's one extra step to this, right? This seems so great. There's going to be more answers than this, all right? So even if I say 0 to 2 pi, 0 to 2 pi, pi thirds, and 5 pi thirds, that's it, because the next one's too big. But if we keep taking half of these, we can keep going. So we got to think for a minute. What would be after 5 pi thirds if I kept going around where cosine equals 1/2? So I got pi thirds, I come around, I get 5 pi thirds. What would this be when I get back up here, past 2 pi? It would be 7 pi thirds. It would be like 2 pi plus pi thirds. And then that would be 7 pi thirds, 8 pi thirds, 9 pi thirds, 10 pi thirds, 11 pi thirds. When I take half of those, what do I get? 7 pi 6 and 11 pi 6?
Yeah, that's...
If I go one more, will that be bigger than 2 pi now? Notice this was a 2 in front of it. How many answers did I get?
4.
How many answers do I normally get? 2. I doubled my answers. What do you think would happen if there was a 4 in front of this?
You can avoid your answers.
You would get 8 answers. If there was a 5 in front of it, you would get 10 answers because you just have to keep going around and then you would divide by 5. I wouldn't. In the Math 137 class that we took, they had a 5x in front of theirs. Just terrible. You could get these same 4 answers if you use one of the identities. I wouldn't use the cosine squared minus sine squared because that one doesn't, that's kind of hard to do. But if you use the 2 cosine squared minus 1 or the other one, like you could get the same answers. But I just want to show you this because I find it to be useful and helpful sometimes if you don't do that. I got one more set of formulas for you and then I'm done, okay? Ready? Here you go. Power reducing formulas. So this is like if you have sine squared, cosine squared, or tangent squared, and you want to get rid of the square, you can use these. These are not used as much as the double angle formulas, but I want to give them to you and maybe give you one little problem to do with it. Again, you don't have to memorize these. It would just be knowing how to use them. Oh, quick, if I can.
I was just pointing at it.
Wait, I had a take-home quiz in my class last Wednesday. That was one homework question, and I used a whole sheet of paper on one homework question. It was easy, but.
That's pretty funny that you said the whole sheet. Yeah, you were there. What'd you say, Zane?
We actually could do a really cool proof of where tangent, actually you could maybe just think about where tangent squared comes from, because tangent squared is the same as sine squared over cosine squared, so if we took this over this, do you agree we would get this? Because the 2's would cancel out? So like we could do a really easy proof of where this comes from, because tangent squared is sine squared over cosine squared. So if you took this formula over this formula, the 2's cancel out, and you get that. I know. Here, Luke, here we go. I got one problem.
Oh my God.
This is it, and we're done with way too much time left for you to work on your homework. Bradley, I'm going to have you take that homework quiz from break after we're done with this, and then I can pass everyone else's homework quiz back. I was grading those yesterday, and I was like, why did I wait till the day before break to do this? And then I had to change 6 hours homework quiz because Zane was telling Blaine in the hallway as I passed what numbers they were, so then I changed it and yelled at Blaine in class. There's a lot of X's. I don't know, we gotta prove it. This is one that you gotta think about. Why do they use U's over here? It's because U could be anything. It could be not just X, not just theta, but it could be something else, like a 2X or a 3X or a 4X. So, does this look like any of the formulas I've given you today? It sure doesn't look like any of those, does it?
Nope. Well, I guess it looks like, yeah, cosine 2u.
Oh, cosine 2u, we said one of them was 2 cosine squared u minus 1. That kind of looks like that, right?
So q is 3x.
And so this is what I mean by you don't have to memorize these. You have to be, but you have to be able to look at the formulas I've given you and try to match up which ones you can use, because they're going to look a little different. So when I see this, it does look like that u is 3x. So if u was 3x, how could I rewrite that over there?
2x. 2u.
Cosine of 2 times 3x,
That's a...
right? Unless you want to write that u equals 3x. My proof's not very good here. I don't have a lot of work to show. This is one of those that's kind of like if you match it up, it works. Which means that's going to work, right? Do you agree that that matches, like that works?
Oh, yeah. For sure.
If you just recognize that the 3x is u. So we could go either way here, but I'm going to change this side to this side. Which means if u is 3x, can I just change this to 2 cosine squared of 3x minus 1? That's kind of a little silly proof, right? It's one of those proofs that I always feel like I didn't do anything, but I think that's it. You could also change this side into the other side. It's really only a 2-step proof. So, again, I think these kind of proofs using the sum and difference formulas of 5-3 or using these formulas are easier because you just have to recognize which formula that you're using when I don't even make you memorize them. So, all right, that's it. That's my notes for today. That's why I didn't print them out, or we would have been done even earlier.
Yeah, today you broke our fingers.
This is homework 5-4. Definitely, I think the beginning of the homework is harder because it's solving those equations, and you do have to kind of think about what to do and separate them. Definitely use our notes to help you.
Go to school past 16. Yeah, that's good work.
27, I have 8 answers. That's exciting, right?
Why did you give us
8.
a